Hello everyone. In this video, I'm going to discuss the derivatives of trigonometric functions. So first we'll start with the derivative of sine u. So u is a function of x. So derivative of sine u with respect to x is given by cosine u times du over dx. So this is our general formula. So for example, if we have u equal to x, so what we get? So our function becomes y is equal to sine x, and then we are interested in finding derivative of sine x with respect to x. So in that case, it would be cosine x. And since here we have x in place of u, right? So it would be dx over dx, and overall we just get cosine x because this is simply 1. So derivative of sine x is cosine x. So that is what you need to remember. But if you have something else in place of x, then we need to use the chain rule, which is shown here. So if you have u in place of x, so then you need to apply chain rule. Let's try another example. So let's find derivative of sine of 3x raised to power 4 plus 2x. So first we take the derivative. So with respect to x on both sides, so it means we're going to take the derivative of sine of 3x4 plus 2x. And now this is our chain rule situation. So we have the outside function. So outside function is sine function, and inside we have the polynomial 3x4 plus 2x. So if you remember, the chain rule was t outside times t inside. So first we take, so derivative of sine is cosine of something times, and then since we notice that here we have x but here we have a different expression, not simply x, so by chain rule we need to take the derivative of that inside function. So d outside times d inside. So let's put this expression here, and in the next step you notice that, so we get cosine of 3x4 plus 2x, and derivative of 3x raised to power 4 would be 12x cubed, and derivative of 2x would be 2. And now, so it's better to write the polynomial in front so that we can know for sure that it's not inside the cosine. So let's write this as 12x cubed plus 2 times cosine of 3x4 plus 2x. So always a good habit to write like this so that we are not confused. We know that this polynomial is outside the cosine. It's in the multiplication. Let's try this example in which we need to use the implicit differentiation to find dy over dx. So this is our implicit differentiation form. So first we need to take the derivative of both sides of the equation with respect to x. So take the derivative of left hand side with respect to x, and take the derivative of each term on right hand side with respect to x. And then, so wherever you have x, y, you're going to use the product rule. So first here, so derivative of sine is cosine. So cosine of xy, and then take the derivative of inside function. On the other hand, we have 2x, and for y term, so you're going to do 3y square, and since we have x here and we have y here, so these are different, right? So we need to use our chain rule, so dy over dx. All right, so now we have cosine xy, so here we need to use product rule. So for any mixed terms, you're going to use product rule. So derivative of, so x as it is, derivative of y plus y as it is, derivative of x, which is just 1. So 2x plus 3y square dy over dx. And since our goal is to find dy over dx, we need to isolate the terms containing dy over dx. So, okay, so let me just first separate out my terms. So, x cosine xy dy over dx plus cosine xy times y. So I'm just going to write y in the front, and then we have 2x plus 3y square dy over dx. And in the next step, dy over dx terms on one side, so inside we have x cosine xy, and also we're going to bring this term on this side, so we're going to combine these two terms together, so that makes minus 3y square here, and on the other hand we get 2x minus y cosine x y. And since our goal is to isolate dy over dx, so in the next step, so we have 2x minus y cosine xy over x cosine xy minus 3y square. And we were able to isolate our dy over dx, so that's what we wanted. So that was our first result, that derivative of sine x is cosine x. So our next trigonometric derivative is for cosine u. So derivative of cosine u is negative sine u, and then since this is x and this is u, by chain rule we also need to take the derivative of u with respect to x. And if we just have simply derivative of cosine x, so here we notice that these variables are same, and then so even if you apply the chain rule, you will end up with just sine x in the end, because dx over dx just gonna be 1. So derivative of cosine is negative sine x. Alright, so let's find the derivative of cosine x cube. So first we're going to take the derivative of cosine, which is our outside function. So derivative of cosine is negative sine of whatever the angle you have. And then since we have x here, but we have x cube here, so we need to take the derivative of x cube by chain rule. And then we notice that the derivative of x cube is 3x squared. So let's bring the polynomial in front. So negative 3x squared sine x cube. So that is our derivative of cosine x cube. All right, so let's try a few more. So if we have to find the derivative of sine 2x times cosine x squared, so in this case, so now we know the derivative of sine and cosine, so we can use the product rule. So u times v, so 1d2 plus 2d1. So let's just use our product rule song. So we know that the derivative is equal to, so what is the formula? 1d2 plus 2d1, right? So first we write u, so our u is this and our v is this. So u sine 2x as it is, derivative of cosine x square plus cosine x square as it is, derivative of sine 2x. Right, so sine 2x as it is, derivative of cosine is sine x square, and by chain rule we need to take the derivative, negative sine x square, by chain rule we need to take the derivative of x square, which is 2x, plus cosine x square as it is, and derivative of sine is cosine 2x, and by chain rule we also need to take the derivative of 2x, which is just 2. So overall here we get negative 2x sine 2x sine x square and plus 2 cosine 2x cosine x square. So this is our final answer. Similarly, if you have something like sine 4x over cosine x cubed, so then you can use the quotient rule. So basically all the rules of differentiation are same, but now since you know the derivatives of sine and cosine, so you can solve any problem that involves sines and cosines and that you need to take the differentiation off. So next result is derivative of tangent u is equal to secant square u du over dx. So if you have just x in place of u, so derivative of tangent x is secant square x, and then dx over dx is just 1. So derivative of tangent is secant square. So again, let's do few examples. So if you want to take the derivative of, let's say we're going to take the derivative of tangent of square root of x. So in that case, so first we know that the outside function is tangent. So derivative of tangent is secant square, whatever angle you have. And then by chain rule, we need to take the derivative of inside. So derivative of square root of x. And derivative of square root of x means derivative of x raised to power half, and now you can use the power rule. So secant square square root of x, and bring the power down, reduce the power by 1, so that is your derivative of square root of x. So overall we get secant square square root of x over 2 square root of x. So that is our derivative. Let's try one more. So if y is equal to 2x plus 3 over tangent 4x, so find dy over dx. So can you guess what rule we need to use here? Quotient rule. Yes, because we have something of the form u over v, so we're going to use quotient rule in this case. So take the derivative on both sides. So y prime is equal to, so quotient rule is low d high. So low is tangent 4x, and derivative of high, which is on 2x plus 3, minus high d low. So high is 2x plus 3. So d low is tangent 4x over square of what's below. So square of tangent 4x. So in the next step, so we get tangent 4x, derivative of 2x plus 3 is just 2, minus 2x plus 3, and derivative of tangent 4x is, so derivative of tangent is secant, so secant square 4x, and by chain rule, the derivative of 4x is 4. So whole thing divided by tangent square 4x. And in the end, we get 2 tan 4x minus 4 times 2x plus 3 secant square 4x. So just a little bit of rearrangement. So tangent square 4x. So that is our required derivative. So in this video, we learned 3 main results. So just a review of what we have learned from this video. So the derivative of sine x is, so what was that? Correct, cosine x. So derivative of cosine x is negative sine x. And the third result that we learned is derivative of tangent x, so that is secant square x. I hope that makes sense. So if you like this video, please hit the like button. And if you are interested in the word problems, so please do watch my next video as well. Thanks for watching.